Welcome back to the channel. Today I'm going to walk you through the core foundations of prompt engineering and the essential patterns that allow you to control AI output with precision and reliability. These are the same techniques used inside the enterprise AI systems. Once you understand them, you will be able to produce consistent, high-quality results, whether you are working with ChatGPT, Claude, Llama, or any other advanced model. So, why prompt engineering matters? Prompt engineering matters because LLMs don't understand the world the way humans do. They don't reason like us. They predict one token at a time based on the information we give them. That means the quality of the output is directly dependent on the structure of the prompt. When the prompt is vague, ambiguous, the AI fills in the gaps using statistical guesswork. But when the prompt is precise and well structured, the AI behaves predictably. In other words, structured input equals structured output. Prompt engineering is simply the discipline of designing that structure. To help you consistently produce high-quality responses, I want to introduce you to the industry-standard prompt formula. Every strong prompt contains 5 essential components: the instruction, the role, the constraint, the context, and the output format. When all 5 work together, the model clearly understands what to say, how to say, and what boundaries to operate within. This formula is the foundation of all advanced prompt techniques, including reasoning prompt, RAGs, agents, and more. So let's start with the component 1, which is instruction. The instruction defines the task. It answers the question, what do you want the model to do? This is where you specify actions like summarize, explain, classify, extract, etc. The biggest mistake people make is assuming the model automatically infers what they want. In reality, the model only does what you explicitly tell it. A clear verb like explain, rewrite, convert, evaluate sets the direction, and the rest of the prompt provides the structure. The next component is role. The role determines the voice and expertise level the model should use. A senior DevOps engineer explains very differently from a lawyer, a doctor, or a 10-year-old tutor. Assigning a role instantly frames the tone, vocabulary, and reasoning style of the answer. It's one of the most powerful levers you can use to align the AI with your needs. For example, when summarizing AWS logs, asking the model to act as a senior cloud engineer will produce a far better, accurate, and relevant response than a generic prompt. Next component is constraints, boundaries. Constraints are the boundaries. They ensure model stays on track. Constraints can limit word count, simplify language, enforce tone, or instruct the model to avoid assumptions or hallucinations. You can specify things like keep this under 120 words, or avoid technical jargon, or respond only with facts from the text. Constraints tighten the model's behavior, reduce noise, and dramatically improve reliability. Next is context. Context is everything the model must consider to answer your request. Logs, contract clauses, error messages, paragraphs from reports, or even personal notes. Without context, the model guesses. With context, the model grounds its answers. Think of it as giving the AI its source material. The more relevant the context, the more accurate the output is. Finally, we have output format, which defines exactly how the model should structure its response. You can ask for bullet points, tables, JSON, markdown headings, or any custom template. Output formatting ensures consistency and allows you to integrate AI responses directly into scripts, dashboards, or automated systems. This is where AI becomes operationally useful because you are not just generating text, you are generating structured, machine-readable output. Now let's look at one of the most important parts of this entire video, the 10 prompt patterns. These are the proven structures that help you get predictable, high-quality answers from any AI model. So let's go through one by one. The first one is summarization pattern. Use this when you want long text condensed into key points. Great for emails, documents, research notes, or meeting transcripts. The next one is explanation or simplification pattern. This tells the model to explain something at different levels. For example, beginner, intermediate, expert, or simplify a complex idea. The next one is role rewriting pattern. Here you can ask the model to write in a specific style or persona. For example, explain this like a lawyer, or like a senior AWS engineer, or like a teacher. Next is extractor pattern. This is perfect for turning messy text into structured JSON, tables, bullet lists, or extracted entities. This is great for automation. Next is classification pattern. Use this when you want the model to assign categories, tags, labels, or risk levels. This is widely used in ML pipelines and document intelligence. Next one is comparison pattern. A simple but very powerful pattern. Ask the model to compare two or more items in a table or bullets. Tools, AWS services, model outputs, or options. Next, template filler pattern. This fills predefined templates like reports, emails, legal letters, Jira tickets with your input. Step-by-step reasoning. Use it when you want clear logical steps. It helps the model think slowly, explain calculations, or walk through a problem. Rewrite and improve pattern. For this, you ask the model to refine the text, improve the clarity, tone, grammar, or rewrite for a specific audience. Perfect for content, emails, and resumes. Last one is validator or critic pattern. This pattern asks the AI to check for errors, missing steps, contradictions, or critique an answer so you can refine it further. Okay, so now let's see how we can implement these patterns into Python code. I'm using Groq client. First, I import the client and OS library. I'm using Groq's Llama 3 model for this demo because it's fast, cheap, and works well for teaching purposes. Right after that, I read the Groq API key from the environment variable. Then I create the instance, and then I set the model name. Okay, so I have defined two helper functions. The first function is called ask. It's the simplest way to talk to the model. It takes single string called prompt, send it as a user message to the chat completion API, and the model returns the text response. So you can think of it as one message in, one message out function. The next one is ask messages. This is the second helper function. It's a bit more powerful. Instead of taking a single string, it accepts full message list. That list can contain system messages, user messages, and if I want to simulate the previous turns in conversations, then I will use ask messages. So this is the format that most modern models expect. It's also the right place to express things like the role of the model in system messages, the actual instructions in the user messages, any few short examples or constraints. So almost all of the more advanced patterns that we are going to demo in this video are going to use ask messages because it keeps the structure of the prompt very clear. Okay, so now let's take a look at the first demo function. It's called demo basic role. Here I build a single prompt string, pass it to the ask function, and inside that prompt I do three things. I give the model a persona. I say what I want, which is explain what I am is to a beginner, and I add a constraint that keep the answer under 120 words. So this is the most compact way to encode prompt formula in one single string. So when I call this function, like here, I print a header, then print the model explanation, and the output is usually short, friendly, and beginner focused because of that role and constraint we set up in this function. So the next function is a demo role with constraints. Shows the same idea but using the full message structure. As you can see, we are calling ask messages function here. So in the system messages, I define the behavior that you are a DevOps engineer and answer clearly and concisely for beginners. And in the user messages message, I put a specific task that to explain the VPC peering, and I use the bullet points to set up constraints. When I call this function now, you can clearly see the answer, and this separation of system and user messages makes the prompt much easier to maintain as the app grows. So let's look at the extractor pattern. The system tells the model exactly what it is, a text to JSON extractor that must always respond with valid JSON and nothing else. The user message provides a natural language invoice and asks for specific keys, which are invoice number, amount, and supplier. When I run this code, a small JSON object is created that I can pass directly in the code. Okay, so summarization pattern. So I fix the behavior in the system message that summarize technical content for busy professionals. And the user message, I enforce the output format that summarize the following text. And I'm passing a long text here. And when I run it, you can see that it has given me a structured and concise summary back. Okay, so we now look at the classifier pattern. So this function implements a basic classification pattern. The system message narrows the behavior that classify text sentiment as positive, negative, or neutral. The user message gives the review text and reminds the model of the allowed values. So this kind of pattern works not just for sentiment only, but any kind of category assignment that you need. So let's run this function and see. Yeah, it just tells you that it's neutral and also gives the reason why it has come to this conclusion. The next one is few short, or it's called in context pattern. So the system message still sets the behavior, return one of these three labels, but instead of just describing the task, the user content now includes three concrete examples. One is positive, one is negative, and one neutral. So after those examples, I'll add now classify this review here, and then a new text. The model picks up the pattern from the examples and apply it to the new input. So this is called in context learning. That is, I am teaching the model how to behave using examples instead of rewriting a long instruction. So let's run this and you see the behavior. The comparison pattern function implements the comparison pattern. The system message say that you compare options in clear markdown table. The user message describe two options and the topic. It asks specifically for columns like pros, cons, and when to choose each option. When we run it, you can see that the result is not just an opinion, but a structured comparison table. It's very useful when you want to evaluate trade-offs like serverless versus containers or different architecture in a way that's easy to read and share. Template filler pattern shows how to use the model as a template filler. So I feed it 4 pieces of information: the issue, the impact, the root cause, and the fix. The user prompt then gives a standard incident report template with a section like issue, impact, root cause, fix, and prevention. So here is what I have passed to it. Let's run it and see how it fills out the template and what it returns. Yeah, you can see that the model has taken the input and filled the template in a clean and consistent way: issue, impact, root cause, fix. So this pattern is perfect for postmortems, change records, any scenario where you want consistent reports from messy nodes. The reasoning pattern function is our step-by-step reasoning pattern. The system message instructs the model to solve the problems, explicitly showing its reasoning steps first, and then give a short final answer labeled final answer. The user message passes in a question, for example, a cost calculation. When I run this function, you can see that the model prints a chain of thought followed by a single final answer line. So it has printed the steps and then one final answer. This structure is very useful for debugging and for building trust in the output on logic heavy tasks. A rewrite improve pattern turns the model into an editor. The system message defined the job, improve clarity, structure, and tone, but keep the original meaning. The user message gives a raw text and asks for only the improved version back. So here I'm passing this text to this function, and let's run this. Yeah, you can see that it has just rewritten it into an improved version of what you have passed. The final pattern is validator pattern, which implements a critic step. So I pass the original question and a proposed answer. The user asks the model to do 3 things: check if the answer is correct, identify what's missing, provide an improved and corrected answer. So this lets the model to act as a reviewer of its own work or someone else's work. So let's run this function. You can see that I'm passing a question and an answer, and it should critic this response and give me a corrected response. Okay, so it gives you 3 sections: whether it's a correct function, is it technically correct, what's missing, and what's the improved corrected answer. So you can see it's a nice way to add a second line of defense against weak or incomplete answers using the same underlying model. So that's the full code walkthrough. And that brings us to the end of this session. Today we covered the foundation of prompt engineering, the 10 essential prompt patterns, and we also saw how to implement each of them in Python code using Groq's Llama models. These patterns are building blocks for everything advanced like chain of thought, React, tree of thought, agents, which we will dive in the next video. If you found this useful, don't forget to like the video, subscribe, and leave a message about which advanced technique you want to see next. Thanks for watching. See you in the next video. And that brings us to the end of this session. Today we covered the foundation of prompt engineering, the 10 essential prompt patterns, and we also saw how to implement each of them in Python code using Groq's Llama models. These patterns are building blocks for everything advanced like chain of thought, React, tree of thought, agents, which we will dive in the next video. If you found this useful, don't forget to like the video, subscribe, and leave a message about which advanced technique you want to see next. Thanks for watching. See you in the next video.